So, how do scientists get really clean results from an experiment without needing a massive group of people? Well, they've got this super clever method, a setup where every single person in the study gets to try everything. And that's exactly what we're diving into today, the powerful technique known as the within subjects design.
All right, to kick things off, let me ask you a question, one that researchers have actually looked into. Does swearing, letting a few choice words fly, does it really help you handle pain? I think we've all wondered about that, right? Well, the way scientists designed the study to test this is the perfect way to get our heads around today's topic.
So picture this. In a real study from 2009, they had people stick their hands into a bucket of icy water. Ouch. In one trial, they were told to repeat a swear word over and over. Then, in another trial, they had to repeat just a normal, neutral word. But here's the kicker, the really important part. It was the exact same person doing both things. They were basically their own control group.
And this whole everyone does everything approach, where one person goes through all the conditions, well, that has a formal name, and it's the heart of what we're talking about today. It's called a within subjects design.
So what does that actually mean? Well, a within subjects design, and you might also hear it called a repeated measures design, they're the same thing, is simply an experiment where every single participant takes part in every single condition. So you don't have a swearing group over here and a neutral word group over there. Nope, you just have one group and everybody does both. You're measuring the same people repeatedly. Makes sense, right?
Okay, so you can probably guess that researchers love this design. It has some huge advantages. But, and there's always a but, isn't there? Like any powerful tool, it's got its own set of problems, some pitfalls you really have to watch out for. So let's get into the power and the pitfalls. The number one advantage? It's just so darn efficient. For starters, you need way fewer people. I mean, if every person gives you data for all the conditions, you don't have to go out and recruit these huge groups. But the real magic is that it gives your experiment more statistical power. And why is that? Well, you're basically getting rid of all the random noise between people. You don't have to worry that, maybe the people in the swearing group just happen to be tougher than the people in the neutral word group. Of course not. They're the same people. This makes it so much easier to see if the thing you're actually testing is having a real effect. Right. That all sounds great. Almost too great. So what's the catch? What's the hidden problem here? Just pause and think about it for a second. What if just doing the first task, say the swearing one, what if that somehow changes how you do on the second task? What if you learn something and get better? Or what if you just get tired or bored?
This is the Achilles heel of the within subjects design. It's such a big deal, in fact, that it has its own name. And for our purposes today, let's just go ahead and call it what it is, the villain of our story. Meet order effects.
So what's an order effect? It's exactly what it sounds like. It's when the order you do things in starts messing with your results. Suddenly, it's not just the task that's affecting you, but the sequence of the tasks. And that is a huge, huge problem for a researcher. It introduces this contaminating element, a confounding variable is the technical term, and it can basically make your entire experiment's results totally useless. And our villain here has two favorite ways to attack. On one side of the coin, you've got the practice effect. This is when people get better at something just because they've already done it once. They learn the ropes. On the flip side, you've got the fatigue effect. This is when people get worse because, well, they're getting tired or bored, or their focus just starts to drift. Yeah, researchers lump these together and call them progressive errors. And the name is perfect because they progress. It's not a one-time blip. It's an error that builds on itself, like a snowball rolling downhill. The longer the experiment runs, the bigger the problem gets. So how do you fight back? How do researchers beat our villain, the order effect? Well, they don't just give up on this really powerful design. No way. They have a brilliant, elegant strategy to neutralize the threat. And that strategy is called counterbalancing. Counterbalancing is all about one thing, shuffling the order of the conditions. It's literally like shuffling a deck of cards before you play. You're trying to make it fair. Now, it doesn't actually get rid of the order effects. That practice or fatigue is still there. But what it does is spread the pain, so to speak. It spreads that error out evenly across all the conditions, so no single condition gets an unfair boost or a handicap just because of its position. Now, there are a few ways to pull this off. You could go for what's called complete counterbalancing. That's where you use every single possible order. But you can imagine if you have more than 2 or 3 conditions, that gets absolutely insane fast. So, a much more common approach is partial counterbalancing, where you use a limited but smart selection of the possible orders. And one of the coolest, most elegant ways to do that is something called a Latin square.
Okay, check this out. This is how a Latin square works. See? You've got your three conditions, A, B, and C. For the first group of participants, they do them in the order A, then B, then C. But look at group 2. They do B, then C, then A. And group 3 does C, A, B. The key thing here is that every single condition, A, B, and C, appears in every single position, first, second, and third, exactly one time. It's a beautifully simple way to make sure that any effect of going first or last gets spread out perfectly evenly. All right, so we have this really powerful design, but it has this big potential flaw. And we also have a clever way to fix that flaw. So how does a researcher in the real world actually decide, okay, is this the right tool for my job?
Well, it really boils down to two main things. First, you've got to weigh the pros and cons for your specific question. Is it even practical? Can you actually counterbalance it in a way that makes sense? And second, and this is so important, you look at what other people have done. You check the literature. Seeing how other experts in the field have handled similar research questions is honestly one of the best ways to know if you're on the right track.
So there you have it. The Within Subjects design is an incredibly efficient, really powerful tool for researchers, as long as they can outsmart that pesky villain, the order effect. So I'll leave you with a little thought experiment to chew on. Let's say you were going to design a study to test if coffee improves test scores. If you used a Within Subjects design, what kind of practice or fatigue effects would you need to be thinking about? And more importantly, how could you use counterbalancing to make sure your results were actually legit? Something to think about.